till now is simple DC circuit. And then we have seen active and passive components. After that, what we have seen is, oops, what happened? So simple DC circuit, active passive components, and then we have seen that in active components there are sources, right, which will act as an active component, right? And then after that, yes. So what types of sources are there? So there are two types of sources. One are independent, second are dependent, right? So independent, again, there are four sources we have seen: voltage dependent voltage source, voltage dependent current source, current dependent voltage source, and current dependent current source, right? And in independent, again, there are two sources. One is voltage source. Voltage sources are of two types. One are practical, another is ideal, correct? Yes, no, this thing we have seen in last lecture.
Yes, sir.
Okay, now let us see further part, right? So further part I will be teaching on your whiteboard, because it's somewhat logical part. Okay, now and then we have seen yeah, so what we will be covering today: what is series network, what is series connection, what is parallel connection, right? And then we know what is Kirchhoff's law, that we have seen in the lecture, how to apply it. Okay, and then might be these examples we have covered in the theory class, correct? Yes, no? So we can see one of the numerical in that. Okay, and yeah, so till this we will be covering today, and maybe superposition theorem we will start tomorrow. Okay, so yes, let us start with our basics. Okay, so I'll go here and we will start with series circuit, right? Okay. So I think series, have you heard this series connection,
Yes, sir.
Yes.
Yes, sir.
right? So what is series? When I'm connecting one resistor after another resistor, okay? That is called a series connection, or maybe I can say in this way that there is positive, negative. So this is a DC power supply, right? Okay. Now, due to application of this power supply, some current is flowing in the circuit. So can I say in this same current is flowing? So the two resistors are said to be connected in series when same amount of current will flow through it, or when one resistor is connected after another resistor, it is said to be in series, right? Is it correct? And the
Yes, sir.
total resistance is nothing but R1 plus R2. Yes,
Yes,
correct.
sir.
Let us say that voltage drop across R1 is VR1, voltage drop across R2 is VR2. So देखिए, जिस टर्मिनल पे करंट पहले हिट करता है उसको हम पॉजिटिव बोलेंगे, जिस टर्मिनल से करंट लीव कर रहा है उसको नेगेटिव बोलेंगे, राइट? सो ऑन दिस टर्मिनल the current is hitting first, so I will call it as positive. यहाँ पर से current लीव हो रहा है, so इसीलिए negative, right? And then we can apply Kirchhoff's voltage law, right? So we can start from this point. हमने बोला था पॉजिटिव से अगर निगेटिव जा रहा है तो कौन सा साइन लेना है हमें? निगेटिव. अगर निगेटिव से पॉजिटिव जा रहा है तो कौन सा साइन लेना है हमें? पॉजिटिव, करेक्ट? एंड व्हाट इज किरचॉफ्स वोल्टेज लॉ? इट इज सेइंग दैट algebraic summation of voltages in a loop is equal to zero. So let us say I am starting from this point, पॉजिटिव से निगेटिव. सो क्या बोलूंगा मैं? माइनस वोल्टेज ड्रॉप अक्रॉस R1. फिर से पॉजिटिव से नेगेटिव बोलिए, क्या बोलूंगा मैं? माइनस वोल्टेज ड्रॉप अक्रॉस R2. And then this current will go here, right? Negative to positive, or what I will call it as plus V, right? Plus V. Okay, and this is equal to zero. So therefore V, I can say it is nothing but voltage drop across R1 plus voltage drop across R2, right? And this you can express in terms of by using Ohm's laws. This will be I into R1 plus I into R2, correct? Yes, no?
Yes, sir.
And
Yes.
this V, I can call it as V into total resistance, and then sorry, I can express it as I multiplied by total resistance. So I will get cancel and you will get this formula. Yes, no?
Yes, sir.
Further, we can say by voltage division rule. VDR means what? Voltage division rule. If you want to find voltage across R1, then it will be VR R1 upon R1 plus R2 multiplied by total applied voltage V. Correct? Multiplied by total applied voltage V. Correct? Yes, no?
Yes, sir.
And if you
Yes,
want to
sir.
find voltage drop across R2, what is that? R2 upon R1 plus R2 multiplied by total voltage V. Correct? Yes?
Yes, sir.
Okay, okay, great. So this is your series connection, right? So I can say if there are if R1, R2, R3, right? R4 up to Rn are in series, right? Are in series. Then RT will be R1
R1 plus R2 up to Rn.
up to Rn, right? And if all is having resistance value is equal to R, then RT will be N times R, correct?
NR.
Okay, great. And then, second is your parallel connection. Parallel connection. So what is parallel connection? Whenever I'm connecting two resistors in parallel with each other, right? R1 and R2. So what is the thing? दोनों रजिस्टर का एक टर्मिनल कॉमन चाहिए और दोनों रजिस्टर का दूसरा टर्मिनल भी सेम पॉइंट को कनेक्टेड चाहिए, राइट? और लेट अस से दैट इफ आई एम अप्लाइंग सम वोल्टेज प्लस माइनस V, right? Then what is the voltage drop across R1? V. What is voltage drop across R2? V. Why? Because voltage in parallel is same, right? So two resistors are said to be in parallel if voltage drop across them is same, correct? Yes, no?
Yes, sir.
Yes.
Now, due to application of this voltage, let us say this I will be generated. So this current will get divided into two parts. I1 will flow through R1 and I2 will flow through R2. So by which formula? By Kirchhoff's current law, I can write I is equal to I1 plus I2, correct? Yes, no?
Yes, sir.
Yes, sir.
So what is this? This is nothing but total voltage divided by total resistance, right? This is voltage divided by resistance 1 plus this is voltage divided by resistance 2. So we will get, so 1 by RT is equal to 1 by R1 plus 1 R2, correct? So RT equal to R1 plus R. So it will be R1 into R2 divided by
R1 plus R2.
R1 plus R2. Is it correct? Yes, no?
Yes, sir.
Yes, sir.
And here what it will come by current division rule, right? वहां पर कौन सा था? voltage division rule था. यहाँ पर current division rule I1 is given by divided by total current R1 plus total resistance R1 plus R2 divided into total current. यहाँ पर ऊपर क्या आएगा? उल्टा आएगा. वहां पर R1 था तो यहाँ पर R2 आएगा. Getting? And I2 we can easily find by R1 upon R1 plus R2 multiplied by I. Yes, no? Correct?
Yes, sir.
Yes, sir.
So this is regarding parallel connection. Any problem in this? Any problem in this?
No, sir.
Okay, is it simple?
Yes, sir.
Okay. So that's this is only given in the PPT, right? Let me just show you so that you can easily refer these things, right? So we can directly summarize this series and parallel connection. Okay. Now this is regarding if three resistors are in series, right? Then yes, current will be same, right? Correct? Yes, no?
Yes, sir.
Because in series, same current will flow. So I1 is equal to I2 is equal to I3, right? Is equal to I. Okay. And here, voltage is same. V1 is equal to V2 is equal to V3. Yes, no? V1,
Yes, sir.
V2, V3, same. Okay. Now, what about currents? Sorry, what about voltages? VR1, VR2, VR3, right? So, total voltage is addition of this voltage plus this voltage plus this voltage. Just now we have seen, correct? V1 plus V2 plus V3. And here there are three currents, right? I1, I2, I3, and total current is addition of I1 plus I2 plus I3, correct?
Yes, sir.
So R total will be equal to R1 plus R2 plus R3, and here 1 upon R total is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Is it correct?
Yes, sir.
Yes. Now let us move on. Oops, क्या हुआ? Okay. So let us see Kirchhoff's current law. All right. So this we have seen. Just a quick revision. Algebraic summation of a current at a node is equal uh, to 0. Correct. So in this case, I1 minus I2 plus I3 minus I4 plus I5 is equal to 0. Correct. Or you can also say sum of the current entering in the junction is equal to sum of the current leaving the junction. Is it correct? Yes, no? ये clear है आपको?
Yes, sir.
Yes, sir.
Okay. So this is Kirchhoff's current law, right? And we can solve any problem by either using KCL or by using KVL. And what is Kirchhoff's voltage law? Algebraic summation of the voltage along a closed circuit is equal to 0, right? So this also we have seen. So we can see couple of examples on this. Okay. So what he is saying, determine the voltage V1 and V3, right? So let us solve this problem, right? Solve this problem. What is saying? Find the voltage V1 and V3. Okay. So can we find the voltage V1 and V3? So let us start analyzing. What is V1? Okay. What is this? Can I say this is plus minus? How much is the voltage? 12 volts.
12 volt.
Okay. What is V1? V1 is this thing. Correct. This is V1. Okay. And V3 we need to find. What is this? This is V2 is equal to 8 volts. Right. So I can say this is your 8 volts plus minus 8 volts, and this is plus minus. Correct? Yes, no?
Yes,
पोलैरिटी
sir.
कैसे डिसाइड किए? यहाँ पर पोलैरिटी ऐसा है, ये प्लस माइनस ऐसा दे दिया मैंने. ओके. तो ये पोलैरिटी कैसे आएंगे फिर इसके? ये आएगा प्लस, ये आएगा माइनस, ये आएगा प्लस, ये आएगा माइनस. इज इट करेक्ट?
Yes, sir.
Yes, sir.
Yes. Now very simple. How much it is? 12. How much it is? 8. Right? Okay. So can I apply KVL in loop A? KVL in loop number A, right? So let us start from here. Minus to plus, plus 12, plus to minus, minus V1, plus to minus, minus 8 is equal to 0. So V1 will be equal to 4 volts, correct?
Yes, sir.
Yes, sir.
KVL in loop number B. So let us start from here in this manner. Minus to plus, plus 8, plus to minus, minus V3, plus to minus, minus 2 is equal to 0. So the V3 is equal to 6. Isn't it? Correct?
Yes, sir.
Yes,
So
sir.
getting? So
Yes,
did
sir.
we calculated V1, V3?
Yes, sir.
Is it
Sir, check lobby, sir.
yes.
Can you check lobby? Someone is waiting.
Who is waiting? No one is there. Okay.
Sir.
So this is application of Kirchhoff's voltage law. Simple, right? Okay. Now, this you can solve it. Now, can you find the current in the given network? Can we find the current in the given network, right? So let me solve this problem also for you. Oops. गड़बड़ हो गया क्या? Okay. Yes. So can you see my screen? What we need to find in
Yes, sir.
this circuit? What we need to find in this circuit?
Current.
Current. Okay. Great. So now I can, this is loop number one. So I can apply KVL in loop number one. Before applying, I'm assuming the direction of the current. So this is incoming. So that's why here it will be plus, here it will be minus. Again, here it will be plus, here it will be minus, right? And in this, again, I will just apply in some opposition. So here it will be plus, here it will be minus, here it will be again plus and minus. Is it correct? Yes, no?
Yes, sir.
Okay. Now, can I apply KVL in loop number one? So let us start from here. Minus to plus, plus to minus, minus. What is voltage drop across this? What is the current flowing in this 1 ohm resistor? I1, correct?
I1.
So it will be I1 multiplied by what is resistance? 1, correct? And
1.
then again plus to minus. What is the current flowing in this resistor? Plus to minus minus. I1 plus
I1 plus I2.
multiplied by 18 is equal to
18.
0. Is it correct? So therefore it will be 18 I1 minus 18. So minus 19, right? So it will be minus 19 and then it will go to that side. So I1, correct? And then it will be minus 18 I2 वहां पर जाएगा तो plus 18 I2 हो जाएगा is equal to 10. So can I say this is equation number 1? Yes. Again we will start
Yes, sir.
in the anti-clockwise direction, plus to minus to plus, plus 20, plus to minus, minus, what is the current flowing? I2 multiplied by 2, right? Again plus to minus, minus, what is the current flowing? I1 plus I2
I1
multiplied
plus
by
I2.
18 is
18.
equal to 0. So therefore this will be 18 I1, right? And then this is 22 and 18. So it will be plus 20 I2 is equal to 20. This is equation number 2. Is it? Yes, no?
Yes, yes, sir.
So you have the scientific calculator. So these are two equations, two unknowns. Can you get the value of I1 and I2? Come on.
Yes, sir.
Yes. So there is scientific calculator in that you just have to put the coefficients and you can get the answer. So anyone who have solved it? Come on. Yes? Got the answer? Yes or no?
Yes, sir. Sir, I1 was assumed in the wrong direction. It's opposite.
No, no, it's okay. Minus will be doing, na?
So minus 2.85.
Minus 2.85, okay, amperes. And here
3.57.
3.57 amperes. Okay, that is okay. If minus is coming, that is okay. We have to write the same thing. Okay, so let us check. Let me check. So minus 2.85 and 3.57. So correct. So we got the same answers, right? Okay. So now I just expect that. Okay, can we do this problem? Can we solve this problem? So let me take this to our PPT. So what is the question? The question is for the determine the supply current and source EMF, right? Means what we need to find? We need to find E and I. Is it correct? Yes. We need to find what is I, what is the value of I, and what is the value of E. What is the value of E? Okay. So first of all, let us solve this problem, right? So what we can find? Just see the circuit. Across any resistor, can we find voltage or current?
Yes, sir.
So before that, assuming the directions, right? What will be the direction current is leaving? So this will be minus, this will be plus, correct? यहाँ पर current is leaving, so this is minus, this is plus, correct?
Yes, sir.
यहाँ पर voltage है, this is minus, this is minus, and this will be minus. Is it? Direction से लिए पता चल गया? Yes, no.
Yes, sir.
Yes, sir.
Yes, sir.
Current is going inside this terminal, so this is positive. Current यहाँ से लीव हो रहा है, तो negative going positive negative. यहाँ पर जा रहा है, यहाँ पर भी जा रहा है. So जहाँ से लीव हो रहा है वो negative, जहाँ से जा रहा है वो positive. Correct?
Yes, sir.
Okay. So what we can find? We can find voltage across R4. This will be I4 into R4. Is it correct? So I4 is given 3, R4 is given 8, so it is 24 volts. Is it okay? So
Yes, sir.
24 volts hai. Voltage in parallel is same. So can I say VR4 will be equal to VR3, that is equal to 24 volts. Correct? So ये भी 24 volts बन गया. Yes, no?
Yes, sir.
Okay. And then, you can find I3. I3 is nothing but voltage across R3 divided by R3. So how much it is? 24 divided by 16. How much it is? 3 by 2.
1.5.
1.5 amperes. Correct? So, this is 1.5 amperes. This is 3 amperes. Right? So you can apply KCL at node, let us say Z. This is node Z, right? So यहाँ से current क्या आ रहा है? I, right? So can I say I is nothing but 1.5 plus 3, that is 4.5 amperes, correct?
Yes, sir.
So I का value मिल गया मुझे, कितना है आपका? 4.5 amperes, right? So can I get VR1, and can I get VR2? Yes?
Yes, sir.
Yes, sir.
Yeah. So what is VR1? Voltage drop across R1 is nothing but R1 into capital I. So what is that? 8 into 4.5.
36.
So it will be 36 volts. And VR2 will be equal to R2 into I. So that will be 6 into 4.5. So how much it is?
27.
27 volts. And then can you apply by Kirchhoff's voltage law in this complete loop? Right? What is the Kirchhoff's voltage law in this complete loop? Right? You have to start from here. This is minus to plus E. उसके बाद में plus to minus VR1, then plus to minus VR2, and then plus to minus VR3 is equal to 0. Right? VR4 नहीं तो VR3, दोनों में से एक ही लेना है, क्यों? Voltage is same. Correct? E minus VR1, how much it is?
36 volt.
36 minus 27 minus 24 is equal to 0. So what is E? E is nothing but 87 volts. Is it correct?
Yes,
Yes,
sir.
sir.
Getting? So simple hai?
Yes, sir.
Okay. So this was numerical based on your simple KVL and KCL. Okay. Now two numericals are there. So with solution, I expect that you should try it at home. Any difficulty in this? Basic things, KVL, KCL?
No, sir.
No, sir.
Is it simple?
Yes, sir.
Yes, sir.
So Now next is superposition theorem, Union's theorem, and then there is a simple star to delta transformation, and that is end of the syllabus, right? So again, we need 2 lectures, right? Maybe we will have a lecture on Saturday, correct? Yes, no?
Yes, sir.
Sir.
So shall I extend the lecture and shall I complete the syllabus till Saturday? Or shall we keep one lecture after midterm? That will be okay, right? Hai.
Yes, sir.
Yes, sir.
Yes,
One
sir. After
lecture after
midterm.
midterm.
Okay. So Aniruddha, you may stop recording the lecture. Did you stop? Yes, Aniruddha. Are you present, Aniruddha? Am I audible?
Yes, sir. He is there.
Okay. तो उसने stop किया?